All right, so we've got an example, y equals the arc sine of x. Now, arc sine, another way to say arc sine is the sine inverse of x. So those two things are the same thing, arc sine and sine inverse. Some textbooks use them interchangeably. Okay, so I wanted you to make sure you understood the notation for that, something you probably should have covered in pre-cal. All right. So what I want to do is I want to find y prime using the theorem 2.7.1. Okay, so we talked about this theorem just a second ago. That theorem basically says that the inverse derivative is equal to 1 over the derivative of the original function. Okay, so I'm going to let f inverse be the inverse of sine, arc sine. And so that means that f is equal to sine of x. Okay, so the inverse of the inverse is the regular, and the inverse of sine inverse is sine of x. Now, if I say y equals a sine inverse of x, the sine inverse produces an angle. The sine of x gives you the ratio of the opposite divided by the hypotenuse. Okay? So sine trigonometric functions give you ratios of right triangles. Inverse trigonometric functions give you the angle of those acute angles on the right triangle. So if I solve this to get rid of the sine inverse, I do the sine of sine inverse of x, and that gets me x. But then I do the sine of y, and that gets me sine y there. Okay, so I just sine both sides to get that. So now I've got a triangle with an angle y, and this is defined to be x, which is x over 1. So opposite the angle divided by the hypotenuse here. So opposite is x, and then the hypotenuse is 1, x over 1. Now, I can use Pythagorean Theorem, a squared plus b squared equals c squared right here. So I'm using Pythagorean Theorem to find this side here. I need to solve for a, so how do I do that? I subtract x squared from both sides. And now this is squared, so I need to square root. And whenever I square root, I get my side here. Okay? So this adjacent side here is equal to the square root of 1 minus x squared. Now, why is that important? Well, I have the function f of x equals the sine of x. So the derivative of f of x is cosine of x. Okay, that's the cosine of x there. So what does this mean? That means y prime is defined to be 1 over the derivative, right? So remember, it's 1 over the derivative, okay? 1 over the derivative of f, right? Evaluated at, well, f inverse. What is f inverse equal to? F inverse is sine inverse of x, so that's what I plug in there, okay? Now, from my triangle, okay, what do I know sine inverse equals? Sine inverse is equal to f inverse, which is equal to y. So this is my angle. So this gives me the angle here. And so that is y right there. So it's the cosine of y. Now, what is the cosine of y? Cosine, so I'm going to teach you a little trick here. Some old hippie caught another hippie tripping on acid. Okay, this is how I remember it. So some old hippie, that sine equals opposite over hypotenuse, caught another hippie that's adjacent divided by hypotenuse. So this is the one we're looking for. Tripping, opposite over adjacent. Okay, tripping on acid, right? So we're dealing with cosine, so that's the c. So it's adjacent divided by hypotenuse. So that's the square root of 1 minus x squared. So this becomes square root of 1 minus x squared. And so this is my answer right here. The derivative of arc sine inverse of x, is 1 over square root of 1 minus x squared. Okay. You can also find this. I personally think this is the easiest way to do it. I like to implicitly take the derivative. If I were to implicitly take the derivative of sine y equal to x, this is d dx here and d dx here. Well, the derivative of x is just 1. The derivative of sine of stuff is cosine stuff times the derivative of the stuff dy dx. And so if I divide both sides by the cosine of y, then I have the derivative equals 1 over the cosine of y. And I know the cosine of y is square root of 1 minus x squared. So that's square root of 1 minus x squared in the denominator. And so that gets me the same answer there. Okay? So personally to me, I think that's the easier way to go. But whenever it says to use the theorem, that's what it's talking about doing here. Okay, let me get back. It takes a while to get back. But what does that theorem say? It says that y prime is equal to 1 over the function's derivative evaluated at the inverse function. Okay, so a little bit different, but it gets the job done. Okay. All right, so therefore we know that the derivative of sine inverse is 1 over square root of 1 minus x squared, something you need to memorize. Let's find the derivative of tangent inverse, okay? So first what I'm going to do is I'm going to let y equal the tangent inverse, and then I'm going to tangent both sides. So I'm going to run the tangent on this side and the tangent on this side. The tangents cancel, so I get x equals the tangent of y, okay? Remember tangent, tripping on acid, opposite over adjacent, okay? Tripping on acid, right? So when I draw my triangle, I want to be opposite over adjacent, okay? So that means I have x on this side and 1 here. So I can use Pythagorean Theorem, a squared plus b squared equals c squared, with 1 here and x here, and then c squared. Well, guess what? I want c, so I take the square root, and that's where this comes into play right here. Okay? So using the triangle is really helpful. So what am I going to do? I'm going to take tangent y and x, and I'm going to implicitly take the derivative with respect to x. And so the derivative, a tangent of something, is equal to secant squared of the something times the derivative of the something, that's dy dx. This is equal to the derivative of x, which is 1. And so to solve, I need to divide both sides by secant squared. And if I divide both sides by secant squared, I get 1 over secant squared of y. Now, what is the secant? Secant of y is equal to 1 over cosine of y. Okay, so it's a reciprocal, right? So got to be careful here. You're dealing with a reciprocal here, all right? So the reciprocal means if cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. So hypotenuse divided by adjacent, okay? So that means that the denominator is literally this radical here, okay? The hypotenuse divided by the adjacent. Well, if I divide something by 1, it doesn't change anything. So this in here is the hypotenuse, okay? Secant squared, right? And so when I square the square root, what happens? Those cancel each other, and I'm just left with 1 plus x squared, okay? So what does this tell me? It tells me that the derivative of arctangent or tangent inverse is equal to 1 over 1 plus x squared. So whatever that something is in here, I square that something right there. Okay? And if it's, if it's not exactly the same thing in there, then I need to use a chain rule. But that's the rule. Okay? Now, using the theorem, kind of like we used up here, we start with the inverse. So what do I know? I know that the inverse is arctangent of x. And so if I do f of x, that's the tangent. The inverse of the inverse is just the regular function, f of x. And so the derivative of tangent is secant squared. And so I have 1 over the derivative evaluated at the inverse. So 1 over the derivative evaluated at the inverse, that's the definition here. And so this becomes 1 over the derivative, which is secant squared, evaluated at the inverse. F inverse is arctangent, okay? And so this gets me 1 over the square root of 1 plus x squared. You always end up, you're going to have to end up drawing the triangle because look, this thing in here is an angle. That's an angle, theta. You can call it y, whatever, but when you draw your triangle, okay, if y equals the tangent inverse of x, right, then you've got to solve. You got to tangent both sides. So tangent y equals x over 1. So you need to call an angle theta. That's an angle, right? And then x over 1, and that's how you set up your triangle, just like we did here, okay? So you still end up having to set the triangle either way. Personally, I think it's easier to set up your triangle and implicitly take the derivative, but whatever works for you. If you're more of a formula person, you're still going to have to set up the triangle at the end of the day, okay? Now, I'm putting this out here for you for reference, so just get this written down, copied, but you got your sine function, the domain, the range, the inverse function. This, when we restrict the sine function, because sine is good for, if you think about the sine function, it looks like this, right? And it goes on forever, and positive infinity, and forever negative infinity. So the problem is it doesn't pass the horizontal line test, so the inverse isn't a function. But if we restrict the domain to negative pi over 2 to pi over 2, and then all of a sudden the inverse is a function with domain and range flip-flopped, okay? So I just want you to write these down so that, or take a picture or whatever you got to do to reference whenever you're going through this. So that you know what the domain and the ranges are for the sine, the trig, all the trig functions. These are all the trig functions, and then these are all the trig inverse functions. Okay, important for you to know that pre-cal stuff. All right, now bunch of derivatives here. Okay, we derived this one here. All right, we did, and then we derived this one here. You can derive all of the others in the same way that we derived the first two, or number 1 and number 3, okay? You set it up, so for example, if I was going to do the secant one, right, I would just say y equals the secant inverse of x, and then I secant both sides, so I have the secant of y equals x, right? And then I take the derivative implicitly, okay? You can set up your triangle at this point. What do you know? If the secant of y equals x, then the cosine of y is 1 over x, right? So if you set up a triangle, and we had y as my triangle angle, cosine, well, what is cosine? It's 1 over x, which is adjacent over hypotenuse, okay? Remember, it's the reciprocal. I'm using the reciprocal fact here. if you remember that secant is hypotenuse over adjacent, then you're good to go. No biggie there, okay? So then what's going to happen? Well, Pythagorean theorem shows me that this is x squared minus 1 squared, which is just 1. And when I take the derivative, well, let's see. What if I have secant y equals x? The derivative of x is just 1, but the derivative of secant is secant y tangent y times dy dx. Okay? So I got to divide both sides by secant y tangent y. Well, I know secant y is x, so that's going to get me, sorry, this is kind of getting crammed, kind of impromptu. So that gives me x for secant y, but the tangent of y is opposite over adjacent, so that's where that square root x squared minus 1 comes into play. And so that absolute value, we're talking about this distance here, needs to be positive. Okay? All right, so that's kind of how you would derive those if you were interested in deriving them. I'm not asking you to derive them, but I am asking you to memorize them. Write them down, put them on a note card, whatever you got to do. If you memorize these, it's going to make life way easier for you for the rest of the semester, and then also into Calculus 2. These pop up in Cal 2 everywhere, okay? So you really need to memorize these, okay? So all these derivatives, okay, very important, right? Especially this one and this one. I like this one and this one because, look, I don't know if you noticed, the only thing that's different between these is that these are negative. So really you're only memorizing 3, okay? And then you got your same trick with the trig functions. The c's are negative, okay? So if you can memorize the sine, the secant, and the tangent inverse, all those inverses, then all you have to do to get the cosine, cosecant, and cotangent are knowing that they're the negatives for the cofunctions, okay? All right, so that concludes